This is from practice test 3, the math no calculator section. Only heart of algebra questions, and there are 8 of them. Number 2, if 3r is equal to 18, what is the value of 6r plus 3? If we notice 3r is exactly half of 6r, what we can do is we can take this equation from the left and multiply both sides by 2. This gives us that 6r is equal to 36. So we can replace the 6r from this equation on the right with what it's equal to, 36. And we get 36 plus 3 is equal to 39. Number 4. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations is true? So between 1776 and 1849, 30 states joined, and between 1850 and 1900, X states joined. Additionally, we know that this top row is twice the number of the bottom row. So 30 is equal to 2 times x. Number 6. 2x minus 3y is equal to negative 14. 3x minus 2y is equal to negative 6. If xy is a solution to the system of equations above, what is the value of x minus y? None of the coefficients for the x or the y terms are 1, and I cannot use straight elimination. It won't cancel out either term. So I'm going to set this problem up for elimination by multiplying the entire top equation by 3 and the bottom equation by 2. This will give me 6x for both equations. So let's go ahead and carry that out. I have 6x minus 9y is equal to a negative 42 for the top. I have 6x minus 4y is equal to negative 12 for the bottom. So if I subtract straight down all 3 columns, my x terms will cancel out. And remember, when I'm subtracting a negative, it's kind of like adding. So negative 9 minus a negative 4 will be like negative 9 plus 4, which will leave me with negative 5y. Similar thing here, I end up with a negative 30. And when I divide both sides by a negative 5, I get y is equal to 6. So if I take y equals 6, and I move it up top, and delete the rest of my board, I can plug that into either one of my original equations. Let's say I choose the top one, 2x minus 3, and I plug in 6 for y, is equal to a negative 14. So this gives me 2x minus 18 is equal to a negative 14. If I add 18 to both sides, I get 2x is equal to 4. And when I divide both sides by 2, I get x equals 2. So if x is 2 and y is 6, what is x minus y? Well, 2 minus 6 gives me a negative 4. Number 8. The line y is equal to kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where c is not equal to 0 and d is not equal to 0, what is the slope of the line in terms of c and d? Well, just like y is equal to mx plus b, I'm going to plug in my point CD into this equation of the line that they give. So I have d is equal to k times c plus 4. They want me to solve for the slope of the line. K represents the slope of the line. So to solve for k, I want to get it by itself. I'll do this by subtracting 4 from both sides to cancel that out. I have d minus 4 is equal to kc. I'll divide both sides by c. This cancels out, and there is my answer. D minus 4 over c. Number 9. Kx minus 3y is equal to 4. 4x minus 5y is equal to 7. In the system of equations above, k is a constant and x and y are variables. For what value of k will the system of equations have no solution? Well, remember graphically, when a system of equations has no solution, that's because the lines are parallel. They never cross. So if we rewrite these two equations in slope-intercept form, we can identify what k is. So let's go ahead and solve both of these for y. On the left, if I subtract kx from both sides, I'm left with a negative 3y is equal to negative kx plus 4. Then I divide everything by negative 3, and I get y is equal to k over 3x minus 4/3. On the right, if I subtract 4x from both sides, cancels out over here, I'm left with negative 5y is equal to negative 4x plus 7. Then I divide all three terms by a negative 5. And I'm left with y is equal to 4/5 x minus 7/5. So if these lines are parallel, then their slopes are equal. Or in other words, k over 3 is equal to 4 over 5. I can get k by itself if I multiply both sides by 3. Cancels out the 3 on the left, and I get k is equal to 12 over 5. Number 15. C is equal to 5/9 F minus 32. The equation above shows how a temperature F, measured in degrees Fahrenheit, relates to a temperature C, measured in degrees Celsius. Based on the equation, which of the following must be true? We can test this first case by creating a table. It claims that a temperature increase of 1 degrees Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. So if I start out with 33 degrees Fahrenheit, I plug in 33 here for F, I subtract 32, I get 1, multiply that by 5/9, it's 5/9. My next number is 34. When I subtract 32, I get 2. If I multiply that by 5/9, I get 10/9. Notice I'm increasing by 5/9. The reason why I chose 33 and 34 was because of that minus 32. Really, it was like choosing 1 and 2. To figure out if this second equation is true, I can take my original equation, C is equal to 5/9 times F minus 32, and I'm going to solve it for F. To do this, I'm first going to multiply both sides by 9 over 5. The 9's cancel out, the 5's cancel out. I have 9/5 C is equal to F minus 32. Then I'm going to add 32 to both sides. And I get 9/5 C plus 32 is equal to F. Well, this is a linear equation, and my slope is 9/5. If you divide that out and get a decimal, it is actually 1.8, which is equal to the increase in Fahrenheit. We can use this same equation to figure out if number 3 is true. If a temperature increase of 5/9 degree Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. So every time we plug in a larger number for Celsius, we are multiplying that by 1.8, not 5 over 9, instead 9 over 5. So 3 is in fact not true, while 1 and 2 are. Choice D. Number 17. If 7/9 x minus 4/9 x is equal to 1/4 plus 5/12, what is the value of x? The first thing we can do is combine like terms on the left side. Because we are dealing with 7/9 x and 4/9 x, they have the same unit, ninths. If I start with 7 of them and subtract 4 of them, I'm left with 3/9 x. The next thing I might notice is that if I triple the values on this 1/4 on the top and bottom, it becomes 3/12, which I can then directly add to 5/12 and get 8/12. So I have 3/9 x on the left is equal to 8/12 on the right. If I divide both of these numbers on the left by 3, then I will get 1/3 x. And if I divide both of these numbers on the right by 4, I will get 2/3. Then I can multiply both sides by 3, which allows me to cancel out the denominators, and I have x is equal to 2. Number 19. At a lunch stand, each hamburger has 50 more calories than each order of fries. If 2 hamburgers and 3 orders of fries have a total of 1,700 calories, how many calories does a hamburger have? I don't think most students have a problem writing down that 2 hamburgers plus 3 fries is equal to 1,700. But this language that each hamburger has 50 more calories than each order of fries can be confusing. Which one do you write first? And really this means that each hamburger has 50 plus f. We can definitely use substitution here because the h and the f both have 1 as a coefficient. The question is, which one? The problem asks, how many calories does a hamburger have? So if we were to just plug in 50 plus f here for h, we will have eliminated all of the h's. We'll be left with only f's, and we'll solve for how many calories a fry has. That's not really what we want. So instead, we can solve this for f first by subtracting 50 from both sides, and we get h minus 50 is equal to f. Then we're going to plug this into our original first equation, where f will be replaced with h minus 50. So we have 2h plus 3 times the quantity h minus 50 is equal to 1,700. If I distribute the 3, I get 2h plus 3h minus 150 is equal to 1,700. If I combine like terms, I get 5h minus 150 is equal to 1,700. If I add 150 to both sides, I get 5h is equal to 1,850. And when I divide both sides by 5, I get h is equal to 370.